Hello, people. This is Lab 11, Week 11. We have one more week of classes left. And what I would like to do today is uh, discuss the concept of design table for a part. Remember, this week we started with parameterizing a part on Tuesday, parameterizing a product or an assembly yesterday on Thursday. And today in the lab, I'm going to be discussing the design table for a part. Assuming that everything goes well, when we come back on Tuesday, next Tuesday, I will be showing you how to create a design table for a product or an assembly. And then, of course, on Thursday, I will do a sample test for you. And next Friday's lab is on, of course. And there is a homework that you have to do and show to the GAs, and that'll be our last encounter before the final exam. Okay, good. So, what do I mean by this design table? Well, first of all, let me make sure you understand that there are many ways of doing these problems. There are easier ways of doing design table for a part, but those things do not easily generalize to an assembly or a product. So I will not go that route, okay? And I will do it the way that may look more complicated than it is, but it applies also to assemblies. So first of all, here's how it works. Whether you have a part or a product, this is the sequence of events you follow. You create the parameters as described, as shown in the design table, in the Excel spreadsheet. We'll get to that in a minute. But don't put any units next to them, because I'll be more specific when we get down to that. Now, if you have to create a design table for a product or an assembly, as we will do that on Tuesday, make sure that these parameters that you create are at the product level, not at the part level. Then you create your equations or relations, okay? And once you're done, you're going to ask for the design table. It's going to come back and say, all right, would you like the software to assign anything that is possible automatically? And choose yes, realizing that depending on what you have done, some of those may not go through, maybe misspelling or things like that, or there are certain things that regardless of how well you spell, it's not going to go through, such as the part name. And if that is the case, then you have to associate those things manually. Now, this obviously doesn't make any sense to you because you don't know what it is, but we'll get to it in a minute. So, first of all, how do you create the design table? You already know how to do parameters. How do you create a design table? In this toolbar, where you have f of x, you actually created your parameters by going there. There is, it's something that looks like a monthly calendar, but actually this is supposed to be a spreadsheet, Excel spreadsheet, for example. You click on it, and this guy pops up. I'm going to show you how to do it with the first radio button. Okay, so this is what I'm going to do for you. All right, and yeah, so this year, because if you watch the video from maybe last year or 2 years ago, there may have been a different approach that I had, but that's the way it works now. So here's our first problem. You already remember this problem. I asked you to parameterize this solid model, so you ended up creating parameters that you could go in the tree and change it, and this whole thing resized. But suppose I give you an Excel spreadsheet and I say, look, we don't change these things arbitrarily as we did it in the parameterizing of the model. But these are the things that I guess the company that you're working for makes. These are the dimensions. This is the serial number. Okay. So make sure you create a design table so that when you select this row, the whole thing resizes according to the specification. When you select the next row, the whole thing resizes according to those specifications. So that's what creating a design table means. Okay, so let's go ahead and do that. First thing that you do is you create a spreadsheet like that. I have already done that, so let me go ahead and show you where it is, because you need to do that and you need to upload it when it comes us to grading. Just like you do your part or assembly, this spreadsheet should actually go in that folder. You have to upload it along with other stuff. So here's the first one. I think, let's see now. Problem 1, right there. There we are. This is exactly what I showed you. Actually, I copied this top left corner. Now notice that when I say in this slide, when I say do not include IN, this is what I mean. Okay, or this is what I mean. Notice that you specify your units by putting it next to whatever you've got. For example, if these are length, you put inches or millimeter, whatever. But when you create the parameter, do not call that parameter big X parentheses IN. Leave that IN out. That's what I mean. Okay, so let's go ahead and first, why don't we create our parameters first? Okay, so we go there. This is a part file, so I suggest you start with a part file. You have a choice of creating the parameters now, or you can do that later, but let me do that now. So I'm going to go to f of x, a parameter of type length. First one, there is big X, and let's give it a meaningful value. For example, for meaningful values, what I suggest is you actually use these values, because I've already tested these. These will not lead into any bad sketches and things like that. So 10, 5, oops, this should be Z, right? This should be Z, save. Okay. Yep, look at it. This is a mistake. This should be Z. This should be Z, okay? So we have X, Y, Z, R, T. Okay, bad mistake. You would have caught us later on. Anyway, here's the parameters that's being created. And the value, I said, what did I say? Oh, hang in there. I said 10. Okay, so 10. Another one, Y. And I think the value that I have here in the first row, you can use other rows if you want. 5, and then Z is 3. So this is 5. Another one, Z. That's the padded height. Did I say 3? Yeah. And then what else do we have? We have R and T. R is 1, T is 1. So let's do another one, R. 1. And another one, T. Also 1. And finally, I want in my spreadsheet the serial number or the name of the part also be specified. So that is a string. So let's change the type to string, and let me call this thing okay, string, and then new parameter of string type, and the value of it was serial number, right? And we're going to put that first row AAA or any dummy name. And then we say, okay, notice that these things have been created here. Good. Then we're going to make the nominal part. The nominal part means something that looks like that. Make sure symmetry is respected and everything that needs to be done is done correctly. So on that horizontal plane, I will sketch something like that. Already I see that this is not closed here. So why don't we select this point, control that point, make it coincident, or any way you can bring that thing down. Let's make the symmetry now. So this line control that line, control the middle axis. You make it symmetric. This line control that line, control that line, control the middle axis, also symmetric. Okay. And dimension the stuff that you want to control. For what are those things? There is, let me see. This is X and that is Y. Okay, fine. So dimension, this is going to be X later on. This is going to be Y later on. This is T and this is R. And of course, padded height is padded height. We won't see it here. Exit and then padded. There we are. Okay, good. So we created our nominal part right there with everything that's to be respected, such as symmetry, etc., is done. Now, we're going to go here, knowledge toolbar, right there where you did the f of x, that guy, thing that looks like a monthly planner. You click on it, and this guy pops up. That looks familiar. It's right here. And we're going to use the first radio button, which is already by default, and then it says OK. And then it says, where is your spreadsheet? Go get it. Because notice that if I cancel that, look, it says, when you click on this, it says, go find your spreadsheet. Okay. So for me, it's going to be this one. It was this one, problem one, right? This is open, but that's okay. I'll take it. Here. Do you want to automatically associate columns of the design table and the parameters of the model that have the same name? So that's what this thing was referring to. Then create parameters. Okay, did that. Then create your formulas, if any. We're going to do that. Actually, I forgot to do this. Okay, so let me do that. I skipped B, so let me go ahead and do that. All right, so cancel. No. Cancel. Cancel. Let me delete this because I completely forgot to do my relation. So what do I mean by that? Okay, so here's what I mean. Go to f of x, click on the part. That guy, I want it to be x. Add a formula equal to x. This guy, add a formula, I want it to be y. Okay. That fellow is going to be r. There it is. You can see that. It says r, right? Add a formula equal to r. This fellow is your t. Add a formula equal to, what is that, t? And the padded height is somewhere here. Look for it if you can find it easily. It's right there. See that? This, add a formula equal to z. The only thing that's left to do is that serial number. So I want the part number, go find it. Go find the part number right there. Add a formula equal to serial number. Okay? Say okay. Good. Now, those numbers, remember those numbers that I put in there, will give you this. We haven't created our design table yet. These are the relationships that I said create. These are the equations or the formulas or the relationship that I said. Now we go to the design table right here. I went there prematurely, right before I did this. You go there, and it says, okay, go get it. Go get that pre-existing file, which was the first, this one, this folder, this one, right? Problem one. And it's going to ask me, do you want me to automatically associate anything that I find with the name that you have in your spreadsheet to your model? The answer is yes. And let's see what happened. Ooh, there we are. Look what happened. For example, let me minimize this and go up there. Okay. So right now, it's the first row, right? These are the first row. If you go to the second row and say apply, there is a dimension in the second row. If you go to the third row, apply, there we are. If you want to add stuff to your table or maybe modify because there was a mistake or something didn't go through, so edit table, that's fine. There we are. Can I add another one? DDD, for example, x of, well, let's say 5, y of 2, z of 1, r of, let's make it very small, point 3, and t of, I don't know, maybe 1. What you have to do is you have to save this and then close it. And it's going to come back and say, hey, there's a change, okay? Are you sure, basically? The answer is yes, close it. And there's the last one. Notice that, by the way, every time you select one of these rows, the name of the part changes, okay? So if I go to the last one, this is the last one, apply, there we are. So that's what the design table for a part is. And I have 3 more to do. We can also specify, a material and things like that. Now, the one thing I want to tell you is that notice that in this slide, I said, create the parameters, then create your formulas. Once done, do the design table, means get it basic, get that Excel spreadsheet and say yes when asked. Anything that is not taken care of must be done manually. What do I mean by that? So if you look at this, there is a tab here called association, and there is nothing left here. If it finds the stuff that it doesn't know what to do with it, it's going to be listed here. And then you have to do that manually. You have to find out what is that thing associated with it, and then move on. Okay? So that takes care of our first problem. Okay, so let me close these things. Now remember, when you upload your work, you have to upload this part and the Excel spreadsheet. If you don't, you're going to have a problem. You're going to have a serious problem. Okay, so let's go to the second problem. The second problem is right here. And once again, you have seen this, okay? You have seen this because I asked you to parameterize this thing on Tuesday. We did it in class together, actually. So let's go ahead through the process and the beta here, alpha, or top. I'm just recording these things. And the thickness, the pad thickness is constant here too. It's not another thing that you want to control. And by the way, notice that here we not only have serial number, we also have material. Okay, so let's go ahead and do that. And we're going to use these numbers so that we don't get something that really screwed up. We're going to use one of these rows because it's already tested as the values that I'm going to use for those things. So my L is going to be 10. My B, my L is going to be 10. My length B is going to be 8. Our top is 0.5. Our side is 0.3, alpha is 70 degrees, and beta is 60 degrees. Or you can use any one of the other rows. Okay, fine. So let's go and start with the part file. Part file. Okay. All right. And then we can create our parameters if you want now, or you can do that later. So I'm going to do that now. So we go to f of x. Let's see now. First of all, the stuff with the string. What are the things with the string? One of them is, you know, uh, uh, remember that I when I did this problem, when I did these problems on Tuesday, I said that although I can create the parameter material, but it's done automatically for me. What do I mean by that? Let me cancel that. Let me cancel that. Let me cancel. Let's apply a material to this. Apply material. Where is it? Right there. There's some dummy material. On that aluminum, you say, okay. Notice what happens immediately. It creates a parameter. It's just that I don't want this thing to be called material. I want to call it MAT, right? In the specific in the Excel spreadsheet, it says big MAT. So I can rename it by going to f of x. This material, I would like to change the name of it so that it says MAT. Okay? Notice that it did change. Now I go and create my other parameters. Let's start with the serial number. So string, new material, I'll call it serial number. Serial number. And let's give it some dummy name, AAA. Okay? The rest of them, four of them are length, and two of them are angle. So let's go ahead here, type length, new parameter. Let's start with L, and I said for L, I'm going to use 10. The first row says 10, 10. Another one, B, that's the size on the top, and the value of B in the table, it says 8. I might as well use that. Another one, R top, that's the radius of the circle on the top. And that value in the table says 0.5, 0.5. Another one is R side, big R side. And that value is, it says 0.3 also. 0.3? Yeah, 0.3. The other two are angles. So we're going to change this thing to angle. Click on the new parameters, alpha, and the table says 70 degrees. Another one, beta, 60 degrees. And that's pretty much it. Okay. So all the stuff that I want is done in the sheet. Now I'm going to make my part. So I'm going to go to that vertical plane. I will sketch. I'll sketch that trapezoid, side trapezoid, something like this. And dimension anything that you need. So I need this top. That's going to be later on my B. This is going to be later on my B. This is going to be later on my L. This is going to be the angle alpha. And that's going to be the angle beta. Exit. Padded by 2 inches because you were told that this is 2 inches. So on the top, I will sketch a circle. And I'm going to center that circle, right? Because the problem description, this is very important. Please read your questions on the tests and homework carefully. It says these circles must be centered on those faces. So you have to do that when you create it. So let's go ahead here. Normal view. Okay, let me see now. Yeah, that's good. So let me put a circle here. and we know how to center it. The top line, control the bottom line, control the center, and that's going to be equidistant, I believe. Yeah, that's good. And then the left line, control the right line. Maybe left one I didn't do yet. Control. Okay, good. And the center, again, equidistant. And don't forget that you have to dimension this circle because it's going to be our top later on. Exit, make a pocket all the way to the end, all the way to the last. Oh, last. Okay, good. And then on this side, I will sketch once again another circle centered like that. And you can dimension it and then center it. That's up to you. So left line, control right line, control the center here, equidistant. Top line, control bottom line, control the center, equidistant. Exit, pocket, all the way to the last. You can see it did go all the way through right there. All right, very good. We are pretty much done as far as making the nominal parts is concerned. Now we're going to go, we are done with, we defined our parameter, we create our model. Now we have to go and get our relationships, equations, basically. So we go to f of x. I don't have to do anything with this material, okay? But this one, I do have to do it. I go and say, okay, where's the part number? Part number is somewhere here. I want to add a formula equal to the serial number. And notice that as soon as I do that, this will change. See, immediately change to AAA. Okay, good. Now to get the rest of the stuff, you click on the part, all the dimension will show up. This guy, add a formula, is equal to B. That fellow, add a formula equal to L. That is the angle alpha. It's selected from here, right here. Add a formula equal to alpha. That fellow is beta. Add a formula equal to beta. That guy on the top, this fellow is the top radius. Add a formula equal to R top. I mean, if you make a mistake, you have to go and fix it, basically. And this guy on the side, that radius on the side, I believe is this guy. Yeah, add a formula equal to R side. And we say, okay. And hopefully we did everything. We say, okay. Now what I get is basically the configuration in my first row. Okay, let's check it out. The material must be steel also. Oh, hang in there. Just 1 second here. This material, I haven't done anything to that material. So, but you will see that this is going to get fixed later on. Okay, it's going to get fixed later on. Yeah. All right, let's move on. So now you click on f of x, not f of x, sorry, the design table right there, right there. You click on it. There is a design table. There is a spreadsheet that I have created already. Let me show you. That is problem 2. I have a spreadsheet, that exact same thing that I showed you, copy to top. It's right there, right there. You can see that, yeah. And I'm a little bit concerned about that math. I'll fix it, but well, let's go ahead and see what happens. Okay, so we say okay. It says, where is it? Well, it's problem 2. Don't forget to submit this Excel spreadsheet with your part file. It says, should I automatically associate any names that I can find that actually is in your model? The answer is yes. Okay, pretty much done. Look at the material. Look, it got fixed. So the first row is what you already say. Let me move this thing on the side here. It's going to be exactly what you saw before. The only thing is the material has properly been accounted for. When you go to the next row, apply, it became brass. The name changed to BBB. You can see that. And these are the sizes. Alpha and beta are both 90 degrees. That's why it looks like that, right? Yep, yep. Next one should be gold. It is gold. Now that one, apparently there is a problem with one of my sizes, the pocket. Okay, impossible to create a feature given. So let's see what the issue is. The issue is this pocket, the second pocket. Let's check it, fit it. Let me see. I don't see anything particularly wrong with it. So what I'm going to do, you know what? I'm going to go to my spreadsheet, to my design table right there. To get to design table, all you have to do is to double click on this. You see that? Don't do another one of these because it creates a second design table. Just double click on this. Don't try to click on that because you're gonna have to. It's going to create another design table for you right there. So oh, 20 inches? Was that supposed to be 20 inches? Yeah, it is. 0.75, 0.75. What did I input here? 0.75, 0.75, 60 and 60. Okay, let me go and change one of these. Change one of these things. I'm not sure why it's not doing it there. Edit table. Let me change this R side. Let me change this thing to, I don't know, something doesn't quite look right. 0.3. And then remember, you have to save it and then you close it. You have to save it, otherwise it won't change. Right there, it changed. It says synchronized. Okay, fine. And apply. So that size was obviously there was a problem. I'm not sure why, but anyway, right there. Apply, apply, apply. Okay. Yeah. Uh, okay. Good. Good. So that takes care of this problem. So we say, okay, do not forget when you submit your work for this problem, also submit the Excel spreadsheet. There is no excuse if you don't do it. All right? You get part marks for making something like that, but there's no way for us to make sure that you did it actually. You did it correctly. Okay? I need to see your Excel spreadsheet. Okay, so I'm going to be doing this problem number 3 that you've seen before. I did this thing on Tuesday, but I parameterized it. Okay, it's a single part. I used the parameterization in order to create a set of parameters in the tree so that you could change the size of this thing and material name and you know other things through the through the tree. Now here I want to create a design table on purpose. My design table, I made it so that the units of the length are in millimeters and the angle is in radian. That's on purpose. Now remember that on the final exam you're going to have imperial units, inches and degrees and things like that. But I want to show you that the life doesn't stop there because that's how I'm going to test you. It could be that your units are different in a Excel spreadsheet. Okay, so here's what we're going to do. We're going to start with a part file, and immediately I apply a material here. So apply material on this part, aluminum, and then say okay. And the reason I do that, it's automatically a parameter is created with the name material, which appears in my spreadsheet, by the way. Then I'm going to create your other parameters. So let me do it in maybe name. Let's go to f of x. This is a string. I'm going to call this thing name and give it a dummy description. Say dummy. Okay. Apply. Now the other three, there's two parameters, three parameters of the type length. So let's do that. So length, one of them is the length of the hammer. And because the information in the table is given to me in millimeters, I'm going to type the same thing, 245 or 54, yeah, 45, yeah, mm. Now automatically it's going to get converted into inches. It's going to be 10 inches. If you say apply, you can see that it's almost 10 inches, okay? That's okay. So next one. This one is going to be our handle. 20, what is that? 25, is it 25? 24.5, 24.5 mm. Apply. Is it one inch is 25.4, 2.54? Maybe that's what the problem is. So let me go back here, change these things to 254 millimeter. Apply. Yeah, 10, that's right. So this one is 25.4 millimeter. That's going to become 1 inch. Yep. Okay, and then the next one is going to be our F, radius of the fillet, which is 12.7 mm, and that is going to be half an inch. Yeah, and then there's an angle. Change this thing to angle, and this I'm going to call. Okay, hang in there. So I'm going to say new parameter, and I'm going to call this thing alpha, ALPHA. That's because in the spreadsheet, that's how the name appears. Okay, otherwise it doesn't know what you're talking about. So 0.523598 rad, and this is going to become 30 degrees. You can see that. Okay, so we have defined everything that we needed. Now we're going to create our equation. So click on f of x. Oh, I have to create my nominal part, of course. So on that vertical plane, I will sketch. The nominal part looks like that. This is a hammerhead. Okay, let's dimension the stuff that we want. So we want this to be alpha, but I also need a corner there. So let's yeah, a fillet there. So let me put the fillet there. Okay, I'm going to. It's already dimensioned. Very good. Exit 2 millimeters. 2 inches. Okay. So on that face, I will sketch. On that face, I will. You know what? Actually, just so that it looks a bit more realistic, so I'm going to go to this part body, to that sketch. I'll make this thing a little bit bigger. Okay, exit. All right, good. So on that face, I will sketch a circle, and then dimension it. This is going to be the radius of the handle, but then I want to center too. So left line control, right line control the center. You're going to make it equidistant. Same thing from the top line, there's the line, control bottom line, control the center of the circle. Once again, equidistant. Good. Exit, and then padding. Okay, fine. Now, we created our equations, which are right here. Where are they? Now, sorry, this is the nominal part. Now we're going to create our equations. So, because if you go through this description, it says create the parameters. Of course, create the nominal part. Create your equations. There we are. Right there. We created the parameter, create the nominal part, which I haven't indicated because that's a must, and then you create your formulas or equations. So what we're going to do is we're going to go to f of x and click on the part. Okay, so let's start putting these things there. So this is the radius of the handle, add a formula equal to RH, radius of the handle. This one is the length of the handle, add a formula equal to LH. This one is the fillet radius, add the formula equal to RF. And finally, this angle is alpha, add the formula equal to alpha. The only thing that's left to do is that name. Okay, so what you do is you go and find the part number. There's the part number, add the formula equal to this dummy name. And that's pretty much it. Okay, so this thing is based on the first row. Okay, but these are the numbers I use for the first row, and that's what you're going to get. No problem. Very ugly. Okay, so now we're going to create our design table right there. You say okay. It says, where is it? So that spreadsheet I've already created, it's over here. It says problem 3, and it's really that guy. Okay. Say okay. It's going to ask you, should I automatically try to associate things with the same name? The answer is yes. And look at what happened. There we are. So what we just did is the first row. So if you click on it and apply, nothing is going to change except for, nothing is going to change because that's how I made my nominal part. If you go to the next one, watch what happened. The name changed, A002. The material changed. And if you say apply, of course, the geometry will change and it's based on this information. When I select the next row, part name changed, material changed, and of course, if you say apply, this is the hammer, 90 degrees alpha. That's how it's going to look like. And then the last one is right here, and we're good. So you get the picture, right? All right. So starting on Tuesday, I'm going to do the same kind of thing for a product or for an assembly. And the main thing there is that these parameters that you created here, they should be done at the product level. All right, good luck.